Here we go again. This is 3 out of 3 of analyzing categorical data. Our first goal is to use bar graphs to compare distributions of categorical data. Our second goal is to describe the nature of associations between two categorical variables. We're going to have to go over our two graphs. Our first graph is a side-by-side bar graph. Side-by-side bar graphs displays the distribution of a categorical variable for each values of another categorical variable. The bar graph groups together based on the values of one of the categorical variables and place them side by side. Our horizontal axis for side-by-side bar graph will be labeled time. Our first set of bar graphs will be morning, and our second set of bar graph would be evening. The vertical axis would be percent, and the bars will be made up of the percentages for morning coffee, which is going to be 50 divided by 100, and that would give us 50%. The next bar that would be next to the coffee bar would be the morning tea, which would be 30 divided by our 100, which is a total for the morning, which would give us 30%, followed by our last morning drink with other, with 20 divided by 100, which is our marginal frequency of morning, which gives us 20%. Similarly, in the evening, we will have a coffee bar graph that would be 20%, a evening tea graph at 50%, and our last bar graph for the evening for the other drinks would be 30%. To remind ourselves how we got all these percentages, we are dividing by the marginal frequency for each of these values. And we'll get the following side-by-side bar graphs. We get our 50% for morning coffee, we have our 30% for morning tea, and we have our 20% for morning other drinks. Similarly, evening coffee drinks, we have our 20%, and evening tea drinks, we have our 50%, and our evening other drinks is 30%. That's our side-by-side bar graphs. We're going to compare these graphs and maybe draw some conclusions. It seems like that in the morning, based on our information, there are more coffee drinkers. And it seems like, based on our data, our frequency distribution, it looks like that there are more evening tea drinkers. Okay, now we're going to talk about our second type of graph, the segmented bar graphs. Segmented bar graphs display the distribution of categorical variables as segments of rectangles with area of each segment proportional to the percentage of individuals in the corresponding category. Let's look at our prior side-by-side bar graph. What we'll end up going to do is take the tea category here of 30%, and we're going to stack it on top of the coffee category of 50%. And then we're going to grab the other morning drinks, and we're going to stack it on top of the tea category. And this will create our segmented bar graph. Similarly, we're going to grab our evening tea category of 50% and stack it on top of the coffee category of 20%. And we're going to grab the other drinks of 30% and stack that on top of the tea category. We just have to make sure that everything adds up to 100%. And here you go. This will be our segmented bar graph. Next up, we're going to look at associations. There is an association between two variables if the known values of one variable help us predict the values of the other. If knowing the value of one variable does not help us predict the values of the other, then there is no association. So from our graph, it seems like that there are more coffee drinkers in the morning than there are in the evening. Similarly, we can think about the tea drinkers in the morning compared to in the evening. It seems like in the evening, there are more tea drinkers. So what we're starting to do here is build an argument. We cannot draw any conclusions just yet with what we have here. We can think about association as describing simple connection between our variables without implying any cause and effect relationship. Let's look at another example using the same side-by-side bar graph. Let's say we have a coffee shop. And in the coffee shop, the data collected will indicate that in the morning, we are more likely to sell coffee. Whereas in the evening, it seems like our data collected will indicate that we are more likely to sell tea. Now let's look at a classic association example. If data shows that ice cream sales increase when the temperature rise, there is an association between temperature and ice cream sales. But this does not mean that the increased temperature is causing the ice cream sales to go up. Note in the last sentence, we want to make sure we understand that there's no cause and effect here. This does not guarantee that temperature causes ice cream sales to go up. Now that we've gone over some examples of association, let's look at an example where there is no association. Let's look at our time frame for both morning and evening. If we're looking at the coffee category, we can see that there's no difference between evening and morning. They're both 50%. This is also true for the tea categories. They are also both set at 30%. And let's look at the last category of other drinks. They're both at 20%. We can also see in the segmented bar graph that all the categories has no unique features between them, meaning there's nothing special between each of the categories of other drinks, tea, or coffee. So side-by-side bar graphs and segment bar graphs is used to compare the distribution of two or more categorical variables. When we compare the distributions, if there's an association, we are simply saying that the two variables are related in some way without specifying the nature of that relationship. This is the end of part 3 of 3 for analyzing categorical variables. We covered bar graphs and circle graphs, and we covered the difference between frequency and relative frequencies for marginal, joint, and conditional frequencies, and covered basic probabilities. And we just did side-by-side bar graphs and segment bar graphs. And that's it. If you learned something, consider liking and subscribing. However, next time we're going to talk about quantitative variables and analyzing their graphs and data. It's time to get out of here.